Okay. All right, we are good. So we have homework today. Don't think I forgot. God bless you, Jhevon. I'm not going to remember that we have homework. I think we have homework for 2 sections. 7.1 and 7.2. Technically we started 7.3, but really didn't do anything. So that we're going to do in detail today. And then that is due next time. So, hold on. Where are we? Does anyone have a syllabus? Yep. I can't find mine. Okay, so the next test covers chapter 7. We've done up to 7.2. I'll finish 7.3 and try 7.4 as well today. 7.4 is very short. It's like one formula. I'm going to say, hey, this is the formula. Use it. 7.6 might take a while, so let's see.
2 weeks.
7.6 I'll do Tuesday. I'll probably spend next Tuesday and Thursday on that. So the next exam would have to be like the Thursday after, which might be Thanksgiving.
We don't see you then.
We'll see you then.
Yeah, so you guys get to go off on Thanksgiving being thankful for the test I will be giving you when you get back. So be aware of that tentative date for test 3. Would be December 1st, I think, is the first day back. Yeah, so by next week I should finish work, and then Tuesday is too soon to give the test, so the 24th is too soon. We have a holiday, so December 1st. I'm pretty sure that's going to be the day. Everything should be done with everything by then. So, here you go.
So when is the last day of this?
Huh? The 14th? The 14th is the last day? Yeah, the last day we have a test on the last day. The last test is on the last day.
We're gonna finish on time, right?
Huh?
We're gonna finish on time, right?
We're gonna what?
Finish on time?
Yeah.
Because most of the classes, they're like really behind, like still on chapter 5.
Really?
Yeah.
Oh. The students, I think there's like at least one class ahead of me, because I see students that come in the tutoring center from other Calc 2 classes, and there are some of them who finished 7.3 already. It's like Pichardo's class, at least I know, is probably one section ahead of us. Really? Others are actually behind them? That's weird.
That's really weird. They watch your videos.
That's totally weird. Because we spent a lot of time on quizzes in this class. Like every week we give like 30 minutes to a quiz. Like I'm very surprised that we're actually. Yeah, it's like it is your fault. I had to do it. I had no choice. Okay, 7.1. I don't know. Homework questions. 35.
Y equals x squared minus c squared. Y equals c squared minus c squared.
Yeah. What were you supposed to do? Find the area between.
When there is 5
Area is
576.
find C. Okay. So the area between the curves is 576. So C, we don't know what that is. But what it might look like is something like this. X squared minus C could look something like that. Right, where this intersection is minus C squared. And then I can have, this is y equals c squared minus x squared, could be something like that, where this goes up to c squared. The intersection would of course be c and minus c. Right? So for the intersections, I said x squared minus c squared is equal to c squared minus x squared. That means that 2x squared is equal to 2c squared, which means that x is plus or minus c. Right? So those are my intersections. And that happens to also be the x-intercepts and y-intercepts of these things. So area we know is 576, which is equal to what? Integral of top minus bottom. All right, that's how you want to think of it. So this is going to be minus c up to c. The top function would be the c squared minus x squared minus the bottom would be x squared minus c squared. So that's 2c squared minus 2x squared. I could use symmetry here, but I don't want to bother. C squared x minus x cubed over 3 between minus c and c. Plug in c, I get c cubed minus c cubed over 3 minus plug in minus c. So this is going to be 4 times 2/3 c cubed, 8 over 3 c cubed, right? Mm-hmm. And then that is 576. So this means that c is equal to 576 times 3 divided by 8, and take the cube root.
C equals 6.
That's actually 6?
Yeah.
Okay, that's nice. So area equals top minus bottom, they put a spin on it though. They gave us the area, and then we had to figure out what C was. Treat C like a regular constant, it's just a number. Don't let it scare you. Other questions?
13. So yeah, there we come back after Thanksgiving, that's the next test. 13. Y equals e to the x. Y equals x e to the x. X equals 0.
Area between the curves?
Yeah.
Okay. So let's find the intersections. So where do these two intersect? E to the x equals x e to the x. This means I have e to the x minus x e to the x equals 0, which means that x equals 1. So, and obviously these two would intersect when x equals 0. X equals 0 and 1 seem to be the main guys here. We could do a sketch, but we don't really have to. E to the x looks like this. What does x e to the x look like? Well, a part of it is negative when the x is negative, right? So that's going down like here, and then there's going to be a part coming
down.
right, but it's going to get steeper, right? So, and we know where this intersects. We just saw for it, it's at 1, and so our curve is going to be like here. This is x e to the x. If we did, let's say you're in an exam and you're not sure what x e to the x looks like because you might be freaked out or whatever, you could have just tested the intervals in like what we did before, right? Just plug in a value in between here, right? And see which one gives you the bigger number. You realize this one gives you the bigger number. Or this one gives you the smaller number. So, how would we set up the area here?
Zero
0 to 1 up. Top minus bottom, right? That's e to the x minus x e to the x. This is the top function, that's the bottom function. Okay, how do you do that?
Just do it one by separating it and then one by parts.
I could, if I'm gonna do by parts, I can do it all at once. If
Yeah.
Just factor out an e to the x. So I can do this as 1 minus x times e to the x dx. Derivative of this, minus 1, derivative of that is 0. Up there, integral of this is e to the x, integral of this is e to the x. So go along the diagonal. This is 1 minus x e to the x plus e to the x. Between 0 and 1. So if I plug in 1, I would get 0, e minus plug in 0, I would get e to the 0 plus e to the 0. So that's e minus 2. Other questions? I feel like error we know already. Homework 7.2. That one's too easy. Top minus bottom all the time. Or right minus left or whatever.
That's too much.
Yeah.
In 47.2?
Yeah, 41 and 42.
41? Okay. What does that say? Jesus, that long I have to read it myself. Let's skip those. I mean, I could do it, but it's not important.
Okay.
So we have to do that for
Number 11.
Because that's not using the disk method or the shell method. That's using the volume equals the integral of the cross-sectional area. So it's not crazy difficult, but it's just
Would we also
too
skip
much of a
36?
detour that I want to
Would
take.
we also skip 36?
36, yeah. If you did it, it's great. It's good that you did it, but for our, it's not going to be on our final. So right now, I don't care.
How about 37
37 in 7.1. Wait, this.
That's both. That's both.
Okay, this is both of them. Find B such. That's a fair question, 37. I wouldn't ask a question like that though, but the concepts you'll need for that are relevant. Yeah, the concepts you'll need for these two are not really relevant to us. I really want to practice things that where you have to use like the disk or the washer method.
Could you do 11? There's 1 plus secant x, y equals 3, and bound to y equals 1.
Especially since we're starting late, I don't want to waste time. Y equals 3. We're going about
Y equals 1.
y equals 1.
So I didn't graph it. I just tried to set out 1 plus secant x equals 3.
Okay, so you try to find the intersection here. Okay, so 1 plus secant x equals 3. This means that
Secant x equals 3.
secant x equals 2. This means that cosine x equals a half. This means that pi over 3. How many intersections would we need though? 2. What's the next one? Yeah, well, how was this phrased? So it's pi over 3 on which one? Okay. Yeah. So those are our limits on our integral. What is that going to look like though?
Is that however, when that
It looks like it sort of looks part of a problem, right? So what does it look like exactly?
A down, smiley face.
Right, where are the bad points? For secant, where does it not work?
raise I want to
So at pi over 2, it doesn't work. At 3 pi over 2, it doesn't work also. At minus pi over 2, it doesn't work, etc. Right? These are all asymptotes. Okay, so now what's going on? Where is it a problem? Like here, it's going to be like this, right? At 1. Right? And then there's going to be another thing down here at minus 1. But we don't really care about that. I'm assuming that they only want one of these guys. Because this will go on forever. So there's also a line y equals 3 coming across here. So this is the region we're thinking about. This intersection here is pi over 3. This intersection here is minus pi over 3. And I'm going around the line y equals 1. So how do we set that up? Let's actually draw this bigger so you can see what I'm doing, especially since we're way over there.
the minimum should be 2.
Yeah, there's a gap. There's a gap.
Should be 2.
The minimum should be what?
Below 1 pass is between 1.
Oh, it's 1 plus. Sorry, I forgot it's 1 plus. Yeah, we're adding 1 to secant. So it looks like that. Looks like that. This is at a 2. This is at a 3. We're going around y equals 1. Because we're 1 plus secant. This is our region here. This is the line y equals 3. This is line y equals 1 plus secant. This intersection here is minus pi over 3. This intersection here is pi over 3. Where are our radius? There's one radius that's going to hit the secant first, right? That's the closest curve, so that's your little r. There's another radius that's going to hit the farther curve. That's your big R. So here, big R is equal to what? Top minus bottom, right? This is at 1, that's at 3. So it's 3 minus 1. So it's just 3 minus 1 equals 2. Little r is going to be what?
1 plus secant.
1 plus secant minus 1. Top minus bottom. It's a vertical distance. 1 plus secant minus 1. So that's just secant. And then we can continue over here. So the volume of revolution is going to be pi times integral of big R squared minus little r squared, dx or dy?
Yes.
Right, we're going around y equals something, so that this method means you switch to dx. All our functions are functions of x. Our intersections were minus pi over 3 to pi over 3. R squared is 2 squared minus secant squared. Okay, how do we do that? All right, that's just 4. The integral of that is 4x minus integral of secant squared. Huh? Tangent. Plug in pi over 3 here, I get 4 pi over 3 minus tangent pi over 3 plus, well, I sort of do symmetry. It's going to be double this. Okay. So this is 2 pi times 4 pi over 3. What's tangent of pi over 3? Alright, think of that as sine pi over 3 divided by cosine pi over 3. You know that sine pi over 3 is radical 3 over 2, cosine pi over 3 is a half. You divide them, you get radical 3. That's your answer. I wouldn't ask you to graph something like secant. Sine is sphere, cosine is sphere, tangent is sphere, arctangent is sphere. I wouldn't really ask you to graph any of that with function. Polynomials you should know. So if I ask you a quadratic or a cubic, you should know how to graph that. If I ask you about straight lines, you should know how to graph those. Radicals, you should know how to graph those. Absolute value, you should know how to graph those. Things like that. Other questions?
Three.
33. A cap of a sphere with radius r, height h. We could actually do that. I'd skip it though. But it's a fair question. You can do it with the disk method. Right? You think of this curve here. Rotate this around the y-axis. You can do it with the disk method. Where the equation for this would be y is equal to, it says radius is r. So it's radical of r squared minus
X squared.
Well, it depends. They define this here, this height here, as h, right? And the radius is r. So this whole thing here is r, which means the distance up to here is what?
R squared minus H.
This is y equals
R minus H.
r minus h, right? That would be your bottom curve. That would be your little r with your thing. Well, that line is r minus h. This line would be what? R squared minus x squared. So you can actually do that. These are the boundary functions, and you would rotate around the y-axis, which is the line x equals 0, which means you set it up as what kind of problem? A dy problem, right? So I'll write these all as x equals something, right? So I can then set up the volume to be pi times the integral. There's only going to be one radius, right? Big R. Big R squared dy. Where big R is just the distance to this, I'd solve for the x. X would be the radical of r squared minus y squared. What are my y values? Well, it goes from r minus h up to r. So remember your r and h, they are just constants. Just treat them as you would numbers. But ultimately, you get the answer that way. So it's not that bad. Problems that are important for us would be like, yeah, like 1 through 17. Like if I'm giving you this on a test, the question will be phrased like that. A region is enclosed by these curves. Rotate it around this and tell me the volume. It'll be something like that. But these are nice problems to work out. It's kind of, at least now, if you're ever in a pinch and you don't remember what's the form for the volume of a sphere, you can actually derive it now. You can think of a sphere as just taking a semicircle and rotating it, right? You can literally just set that up and rotate it, right? Or just put the upper quarter of the sphere and rotate that and multiply the answer by 2. Right, this would just be the equation y equals the radical, whatever the radius of the sphere is. Let's say the sphere of radius 1 minus x squared. Take that as my function and rotate it around the y-axis, and I'd actually get the formula. So that's nice. Are there any ones between like 1 and 17 that were an issue? all straightforward. We'll get to the more interesting problems now when we go through the shell method. Who gave me this? So let's start again. Because the problems really get interesting when you don't know that you have to use the disk, right? What if, it's all a toss-up and you have to figure out which one is the better one to use. That's when it gets interesting, and that's what the test is going to be like. I'm not going to say use the disk method. I'm just going to tell me find the volume. However you find it, just find it. Hopefully you do it in the more efficient way. Also, pretty likely, I might ask you to set it up both ways. Set it up with the disk method, set it up with the shell method, and then evaluate one of these methods. One, you'll see that the integral is a lot easier to do than the other one, and then you just tell me what the answer is. Recap, just to make sure we know about this dishwasher method. Tell me about the dishwasher method. What's the formula?
Pi integral r squared.
Pi times the integral of
Big R squared.
big R squared minus little r squared. Remember, this is outer radius, which is the distance to the farther curve from where you're rotating, and this is the inner radius. How do you know you have to set it up as a dx or a dy?
X-axis.
Right, you think d means different. Right, which means the other thing besides the formula that you need to remember is that if about x equals something, x equals a constant,
dy.
you set it up with a dy. If about y equals a constant, you set it up dx. Something that might cause you a trick, notice that this guy includes the x-axis, right? So the x-axis is actually a y line. So if I'm going around the x-axis, I use dx. And this guy includes the y-axis. So if I'm going around the y-axis, I do it as a dy. Right? So that's the other important fact to see. So basically, if you have those two basic concepts and you have the concepts of measuring distances, just top minus bottom or right minus left, you're good. Right? Then we went to the shell method. Where we think of S as being the same. So that means if we're going about x equals something, you use dx. You just keep it in the same variable. Or if you're going about y equals something, you use dy. Right? The formula for that was the volume is 2 pi times the integral of RH. Right? Where r is the radius, h is the height. Both are distances. So again, we're measuring them top minus bottom or right minus left. Okay, so now let's expound on this. The radius in the shell method is different from how the radius in this method is. Basically, at any given time, the radius is going to be equal to, let's say the dx version. The dy version is the same. It's going to be either x minus the axis or the axis minus x. Right? That's the dx version. Right? The radius in shell method is always easy. It's always a linear function of this form. Right? If you're doing the dy, then your radius is going to be either y minus the axis or the axis minus y. Right? How do you determine what minus what? It's a right minus left or a top minus bottom. That's always what you're doing. It's the distance. Okay. So let's see what I mean. So I'm just going to give you some pictorial illustrations and then we sort of get into the groove of how these things are going to work. So let's say here I have this function. Let's say I want to rotate around the y-axis. And I have my region over here. So this is something like, boom, I have a top function f of x, boom, I have a bottom function g of x, right? This is my region. I want to rotate this around the y-axis using the shell method. Now remember how the shell method works? We cut this guy up into shells, right? The shells are parallel to this guy. So I look at one slice, one shell, right? The radius is going to be, remember, it's always the distance from the axis of rotation to the function. In this case, it's going to the shell. That's going to be my r. Okay? Now here is one thing that we have to know. X equals the location of the shell. Right? Or y equals the location of the shell. In the dy case. Right? So whatever position the shell is at, I call that position x. Always position x, right? So now I want to rotate around the y-axis. What is the equation for the y-axis?
X equals 0.
X equals 0. Okay, so in this case, if I set up something like this, what does my r look like? What does my h look like? H, by the way, is the height of the shell. What would r be? X minus 0. Right? So right minus left thing. Notice that the axis is 0. Right? You think of the axis as being that number 0. So here, r is just x. What is the height? Top minus bottom. What is on top? F of x minus g of x. Right? Then you're going to plug those two into the formula and do your integration. Okay. I have this guy, p of x over q of x. I want to rotate around this time. I want to go around the line x equals minus 2. Tell me what's the radius, tell me what's the height. Here's a shell. My radius measures to that. That's my r. How do I find what's the length r? X minus a minus 2, which is x plus 2, right? Because x is always the location of the shell. So it's right minus left. X minus a minus 2. Height? I'm rotating around y equals 3. What's the radius?
What the heck is it?
The reading might be like
3 minus 3.
The shell is also x or y.
We're in the shell method, right?
Yeah.
I'm going around y equals something means what should be my variable? This means I should be thinking of dy. So no x's should be mentioned. What is going to be the radius? 3 minus y. Remember, I'm going to split this guy into shells. That's r. Y is the location of the shell because I'm in dy. So what's this distance? Top minus bottom. 3 minus y. Revolve around x equals 7. What's the radius? X minus 7. Is that what you think it is?
No.
It's
Right
right.
minus x.
Right minus left. Remember, here is always position x. This is at 7. Right minus left. So it's 7 minus x. What's your radius? 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 Super easy, right? You get it? That's it. That's the radius in shell.
No actual problem.
What?
Those are actual problems.
Well, no. No. Like the R in the shell formula, that's how you'd find it though. It's that easy, right? X or Y is always the location of the shell, and then you do a top minus bottom or right minus left. Okay. And the height is just going to be top function minus bottom function, or right function minus left function. They'll always be opposites. In shell, R and H are opposites. I.e., if R is right minus left, the H will be top minus bottom. If your R is top minus bottom, your H is going to be right minus left. Right? They're both distances, but they're perpendicular to each other, right? The radius will always be perpendicular to the shell, right? So if your radius is a horizontal distance, your height will be a vertical distance, and vice versa, right? If I'm moving up, it means the shell is this way. So if my radius is a vertical distance, my shell will be a horizontal distance, right? But they're still distances, just right minus left, top minus bottom. The location of the shell is going to be X or it's going to be Y. But it's always just X or Y. Right? It's much simpler to find the radius in the shell method than it is in the disk method. The radius is always a linear function of that form. Always going to be the function minus the axis, or the axis minus the function. It's going to be 1. Okay. That is it. What else do I say? So here I said redo the examples that we did for the disk method. So let's just do that. So my examples for the disk method, and then I have an extra example where I said choose your own method. Okay, so let's redo that. Example, R is the region bounded by y equals x squared, y equals 3x. Find the volume. Here, use the shell method. I want to use the shell method because we already did all these in disk. I want you to see the other one. Using the shell method, obtained by rotating R about x-axis, B was y-axis, C was x equals 4, D was x equals minus 1, E was y equals 10, F was y equals minus 2. Okay, we're going to do all those. A. What do our graph looks like? Well, y equals x. Then we had y equals 3x. So that was the region. Our intersections were what?
3, 0, 3.
3 and 0 here. What was the intersection on the y? It was 9. Okay, so we know that's the setup. We are rotating about here the x-axis. So I'm going to rotate around here, right? So I'm rotating around the x-axis. What variable should the form problem be in? dy. Right? right? Because the x-axis is y equals 0. Shell method means same. Okay, so I know it's a dy problem. So it means that I'm rotating here. My radius is measuring towards the shell. It means my shell has to be horizontal. Okay, so that's my r. This is my h going across here. So what's r? What? Y minus 0. I'm in dy, so it's going to be y something. It's either going to be a number minus y or y minus a number. So this is at position y, so it's y minus 0. So that's my r. What is my h? It's a horizontal distance. Right minus left. What's on the right?
X minus
dy. You should not be saying anything with x. So here, this was from y equals x squared, so I have to solve for x. That's radical y here, right? So this is radical y minus, I have to solve for x, so y over 3. So according to the shell method, the volume will be 2 pi times r times h. What are the limits here? 0 to 9. Because I'm doing dy, my limits come from the y-axis. And you do that, you'll realize that it looks very different from the integral you got from the disk method, but you will get the same answer if you do it. It was 162 pi over 5. Right, not a crazy, terrible crazy integral. This you just write as y to the half, multiply out, add the powers, then do the power rule. It's not going to be a big deal. What's the big deal is the setup, knowing how to set it up, and in what variable to set it up in. Okay. E, same region. Right. What I want you to get is the concept, so I'm not going to switch things around too much. This is 3. That would be a 9. This is the region. This time I want to go around the y-axis. Right, so the y-axis is the line x equals 0, which means I should be doing dx, because shell means the same. I keep it in the same variable as the line I'm going around. Okay, so I know everything now is in terms of x's. My radius will be measuring horizontally from the axis of rotation to the function, so the shell must be vertical. So that's going to be a top minus bottom. My r is going to be right minus left. So r is going to be the x. Remember, the position of the shell is x because we're in dx. So what's the radius?
X.
Right, so it's x minus 0. What's my height? 3x minus x squared. Top minus bottom. Which means according to the shell method, my volume is 2 pi times the integral of r times h. Where are the limits? 0 to 3. I'm in dx, therefore my limits come from the x-axis. Looks different from the disk method, but it will give you the same volume. Don't take my word for it, work it out on your own. 27 pi over 2. That's the answer you should get when you work that out. Again, it's something you can use the power rule for. You don't need anything too exotic. C, I want to go about x equals 4. So this would look like boom, 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 boom. That's a 9. X-axis, this intersects at 3, which means I'm going on this line. X equals 4. That's my shaded region. Let's see the okay, so I'm going on x equals 4. What kind of integral? It's a dx. All my variables now should be functions of x. What's my r? 4 minus x, right? My radius is always measured from the axis of rotation going to the function. In this case, the function is the shell. That's horizontal, means this is vertical. That's my r, this is my h. R is right minus left. This is at position x. Therefore, it's 4 minus x. H is top minus bottom. So it's going to be 3x minus x squared. Which means your volume is 2 pi times the integral of r times h. So I'm going to take 4 minus x times 3x minus x squared dx. Limits 0 to 3. It's a dx integral. My limits come from the x-axis, 0 to 3. Looks different from the this method, but you'll get the same answer. The answer should be 45 pi over 2. How do you integrate this? Multiply out, use the power law. D, we're going about x equals minus 1. So I have this guy here, here. So that's 3, so 9. I'm going around x equals minus 1. What's r and h? R is x plus 1, or more specifically, x minus minus 1 equals x plus 1. So my radius is from the axis of rotation to the function. The function is the shell. Radius is a horizontal distance, therefore it's right minus left. And the right has position x, because I'm doing dx. So it's x minus a minus 1, gives me x plus 1. My height is a vertical distance, so that's top minus bottom, which is? Notice that in dx, the h is always the same thing. It's not gonna change. So this means that volume, according to the shell method, is 2 pi times the integral of r times h. X plus 1 times 3x minus x squared dx. Limits are 0 to 3. It's a dx integral. My limits come from the x-axis. So again, 45 pi over 2. Any questions so far? Is it straightforward? Are we getting in the groove? Part E was to go around y equals 10. Okay, how do I do it?
dy.
You know, it's a dy. First thing you think, okay, I'm doing shell, which means it has to be a dy integral. Okay, because it has to be the same. Okay, so I know everything's in functions of y now. So what's going to be my radius? What's going to be my height? Again, radius from the axis of rotation to the function, which means the radius is going vertically. So the radius is going vertically, which means my shell is horizontal.
That's right minus.
I'm in dy, therefore my shell has position y. Therefore, what is the radius? 10 minus y, top minus bottom. What is my height? Right minus left, so this is radical y minus This means my volume, according to Shell. 2 pi times the integral of r times h dy. What are my limits? 0 to 9. I get them from the y-axis because it's a dy integral, just the bounds for the shaded region. (288 pi over 5). How would you integrate this? Multiply out, use the power rule. How do you think of this? Y to the 1 half power, multiply out, you add the powers, do the power rule. Make sure you try it and you get that answer. Where y equals -2 is the final one. Here's my region that I set up. This is a 3, that's a 9. This is y equals -2, that's what I'm going around. Okay, what's the first thing I think? Shell method. Y -2 means it's a dy integral. Shell means the same. R is from the axis of rotation to the function, means it's a vertical distance, which means my shell is a horizontal distance. That's my R, that's my H. Position of the shell, since I'm doing dy, it has position Y. What's the radius? Y plus 2, because it's Y minus a -2. Therefore it's Y plus 2. My height, right minus left. What's on the right? Radical Y. What's on the left? Y over 3. Which means volume is 2 pi times the integral of R times H, Y plus 2. You have to sort of get yourself hype. After a while, you can fall asleep doing one of these things. Which is really the danger in test 3, if you think about it. It's so, the things are so easy that you'll be doing the testing. Yeah, it happened to me. Don't think it can't happen to you. Okay. 252 pi over 5. Should be the answer that you get. Okay. So, do we sort of get the method? Do we get what's going on? Any questions?
What is delta R?
Huh?
The books mention the delta R.
The delta R?
What's that?
It'll just be R. It's just the difference. Yeah, I wouldn't worry about it. Just do it the way I say. You don't need all that technical stuff. Technical mumbo jumbo. Okay, here's the test. Use a method of your choice. Right. I'll put that in brackets because I'm not always going to even say that. Right? Find the R is the region bounded by x equals y squared minus 3, x equals 2y. Find the volume when R is rotating about A, y equals 4, and B, x equals 8. All right, so the first thing I want to do is see what this region looks like. What's the picture?
Radical x of 3. So you start from the right side.
I start from the right side.
Left side, left side.
Negative 3, and then you
So I have negative 3 here,
Yeah.
and then what's happening?
you draw the CC thing.
Going that way. What does x equals 2y look like? Huh?
X over 2.
What's the intercept, the y-intercept? It's passing through 0. What's the slope?
Half.
It's a half, which means it's a positive slope. Right?
Yeah.
So this is x equals y squared minus 3. This is x equals 2y. This is my region. How does y equals 4 come into play? Where is that line going to be located?
We can find the intersects first.
Well, we need to find the intercepts. How do we find the intercepts? We'll call it intersections. You said what?
Empty equal to
Y squared minus 3 equals 2y, which means that y squared minus 2y minus 3 equals 0. How do I solve for that?
minus 3 minus 1.
You can factor it. Be 3 and 1, so it'll be minus 3 plus 1. So my y is either a minus 1 or it's a positive 3. Which means my line y equals 4 is above all this. It's above. Okay? Use a method of your choice. This method might be the best one to use. Shell method might be the best one to use. Choose.
Shell method.
Why would you choose the shell method? Just because, like, whatever?
It's easier.
Why would the shell be easy?
The washer has 2 radii that you have to deal with, and like you have to square them both.
How do you see that? Where would that come in?
Well, because you would have to do, you would have the bottom curve and the top curve. So if you were to do the washer method, you would have a big R and a little r. But if you use
Yeah, that's no problem. Here's my little r.
yeah, but
Here's my big R. What's the
Something
problem?
about the y squared minus 3.
What?
I mean, I
The
think
y squared minus 3, like towards the left, the radii is the same thing.
Oh, look at this. See up to here. Over here, my little r is this guy, and my big R switched. Right? Before my big R was a straight line. Now it's the parabola. That's bad. I would not do the this method if I had a choice here. Shell method is what I'd use.
So if we stay on the same side until we meet
Okay, now I've chosen shell method is going to be better because now I know that my height would be horizontal. Well, okay. So this doesn't seem to be the better one. Does shell actually end up better? You'll see that it actually does because when we do this, y equals 4. Right now my radius would measure from the axis of rotation to the function. My shell would therefore be horizontal, and there's only one thing on the right and one thing on the left. So there's only one thing I have to worry about when doing the shell method, whereas doing the this method, there are 2 things. I have to split this integral in 2. I'm not a big fan of that, so I will not do it that way. So that's my r, that's my h, and I know that this is minus 1, and this is 3. Right? So the shell method is what I'd go with, because over here, I would need 2 integrals for the disk. Right? And here I'm like, oh, I only need 1 integral for the shell method. Okay, now that I know I'm doing the shell method, that I've made my choice, shell is easier, now what?
For the axis is y, so obviously it's dy.
So once I've chosen the shell method, I know dy is what I'm going to do. So everything now is functions of y, right? So the first thing you have to do is choose the method, either disk or shell. You're going to make that choice based on what your region looks like. Once you've made that choice, you're going to figure out what variable should you be in. If you're in the shell, it's just going to be the same as the line that you're rotating around. If you're in the disk, you have to switch it, right? So if disk was better, I'd actually be setting up in dx, right? But shell is better, so I'm setting up in dy because I'm going around y equals something. Okay, so given that, how am I going to set that up? What is r here?
4 minus y.
Square root of x.
4 minus y, right? Because y is the position of the shell since I'm in dy. Top minus bottom is 4 minus y. So that's my r. What's my h? Right, it's right minus left. The right is the line 2y. The left is the parabola y squared minus 3. Is that right?
It's plus 3.
Because you take out it.
Plus
Brackets. Remember what the syllabus said. Use your brackets appropriately. The negative sign is to distribute. So it's actually going to be a plus 3. So this is going to be 2y minus y squared plus 3. Which means, what's the volume here? The integral is from what?
-1 to 2.
-1 up to what was the intersection here?
3.
3. So it's -1 up to 3. I'm on the y. I look at the y guys because it's a dy integral. And I'm going to just take r times h. So this is 4 minus y times this guy. 2y minus y squared plus 3. Okay, how do I do that? Expand it. How do I expand that?
8y minus 4y squared plus 12 minus.
Alright, just take the 4, multiply out. Then I'm going to take the y, multiply out. So 4 times all of that,
8y
I'm going to get 8y minus 4y squared plus 12
minus 2y squared
minus 2y squared plus y cubed
minus 3y.
minus 3y. What do I do now? I simplify. So y cubed, combine the y squares. I have minus 4y squared minus 2y squared minus 6y squared. The y's,
Plus 5y.
I have 8y minus 3y, that's plus 5y.
Plus 12.
And the constants is just 12. So it's plus 12. Integral
Y to the 4th over 4
over 4 over 4 minus
3y cubed.
3y over 3, that's 2y cubed
Oh my bad, 2y cubed.
plus
5y squared over
power 2y squared plus 12y. 2 minus 1 times 3. So I'm going to plug in the 3, that's 3 to the 4th plus over 4 minus 2 times 3 cubed plus 5 over 2 times 3 squared plus 12 times 3 minus, plug in minus 1, you get a quarter plus 2 plus 5 over 2 minus 12. So what's that? Whatever. You get to hear, you get like 9 out of 10 points, like whatever. I can give away that point. I'll get it back in the bonus. You can have that point, Jhevon. Here's a tip. Next. Okay, so, but that's basically the idea. Okay, so that's sort of how you go through choosing what method you'd want to use, and once you've chosen, you know what variable to put in, and once you know what variable to put in, you know what formula to use, you know what formula to use, you know what pieces to put in. Okay, so it just goes like that. We have part B, where we're going about x equals 8, and functions like this with a minus 3, it's like that. These intersections were at 3 and minus 1, which means the intersection for the x would be what? X was 2 times y, right? So this is minus 2. And so this, the x is 2 times y, so this would be 6. And I'm going around x equals 8, so there's a line out here. X equals 8. Dx. Why would you do it dx?
What method are you using?
What method are you using? That's the first thing you have to figure out. What method would you use?
Just use shell.
Just use shell like for everything.
Just use shell?
For everything, yeah.
So my radius is coming over here. It's going to hit a shell that's vertical, right?
Yeah.
Right? Are we cool?
Yeah.
What if my shell is over here? Problems, right? These two height functions will be different. Shell requires 2 integrals. What about this though? This would measure to the closer function and the farther function. Turns out that the line is always the closer function. The parabola is always the farther function. Disk is better here. Which is going to be a washer, technically. But all right, so I know disk is the method I would use, right? So it's the same region. The only difference is I change what line I'm rotating about. Right? I'm not going around a y line anymore. I'm going around an x line, and it actually changed the whole setup. This is the better method here. How would it look? So that's my little r, that's my big R. So once I've chosen this, now what do I need to do?
Axis and then.
So what does this mean? dy. So here I would choose the disk method, which makes it a dy problem. All my functions need to be functions of y.
If we're lucky.
So what's my big R? What's my little r?
Right minus left. So
8 minus something.
Big R is right minus left, so it's going to be 8 minus
The parabola function.
8 minus the parabola function, which was what? Y squared minus 3.
That was in a radical one.
Where was?
No, there's no radical.
No, it was x equals this, right? That's fine. So 8 minus a minus 3 gives me 11 minus y squared. What's my little r?
That was 2y, so 8 minus 2.
8 minus,
That was a 2.
it was 2y, right? So this is 8 minus 2y because it's right minus left. This means my volume is pi times the integral of big R squared minus little r squared. dy, which means my limits come from the y-axis, which is going to be minus 1 and 3 again. Pi times, now I'm going to multiply out and simplify, so this is just 11 squared, which is 121 minus y to the 4th, right? Right, just square this and square that.
Yes, you're right.
Of course you do that, you get 0, and then just, I get away with not grading. So it's 121 minus what? 22y squared plus y to the 4th minus 64 minus
32.
32y plus 4y squared. dy. So again, I'd simplify here before putting all this in. Constants, 121 minus 64, so what's that? Huh? 57. And minus 22y squared, this would be plus 32y squared.
Okay.
So that's what?
This is 26.
Minus 26 was
26 minus.
22y squared, and this is minus 4y squared. Okay, so it's minus 26y squared. That gets rid of the y squares. What else do we have?
That's it.
Nothing else, right? So this is a plus y to the fourth
Yeah.
and a plus 32y. Now we can integrate 57y minus 26 over 3y cubed plus y to the fifth over 5 plus
16.
16y squared between minus 1 and 3. So I plug in 3, 57 times 3 minus 26 times 9 plus 3 to the fifth over 5 minus 16 times 9 minus, in brackets, y is a minus 1, so that's minus 57 plus 26 over 3 minus 1 over 5 plus 16. And that's whatever. We can give Jhevon the point. Get it back in the board.
What's this bonus?
So I'll get like a 98, and then you get like 5 points from the bonus. That's my plan. That's sort of my plan. I'm just gonna get like a 98 and get like 5 points from the bonus, end up with 103. That's sort of like how I. What?
What did you need to get like 64?
Oh my god.
Yep.
Can you explain me again why not method?
Right, because so you have to sort of look at what you would need for a shell method. You need a radius and a height, right? The radius is obviously measured horizontally because you're going from the axis of rotation to the function, which means my height is vertical. Now the height would be measured as top function minus bottom function. So you see here, the top function is the parabola, the bottom function is the line. Over here though, the top function is the parabola, the bottom function is again the parabola. So my bottom function switched, which means my shell, I would need 2 different functions. There's one function when it's over here, and then there's another function when it's over here. So that means I need 2 integrals. However, with the disk method, there's only one function that's the close one and one function that's the farther one. So I only need 1 integral there. So it's just looking at like when you draw this region, you're gonna think, if I'm doing the disk method, what would I need? And then you look at it, and if you like it, fine, you run with it, right? Or then if you need the shell method, what would I need? But as long as you see like there's something where you need 2 integrals, it's probably the other one. There are also cases where, let's say something like I gave you x equals f of y, and this function is really complicated, like I can't solve for y to write it as a function of x, then I sort of have no choice, right? In that case, I just choose whichever one would go with the thing as a function of x. So let's say so there are also cases where, say, you're given x equals f of y, and this guy is actually hard to solve for y, right? That would mean must do it dx, dy, right? Because I have my functions in terms of y, so I have to do dy, which means at that point I know if I'm going about x equals something, I would have to choose what?
If it's this.
Yes.
I would have to choose this method, right? Or I know that if I'm going about y equals something, then I choose the shell method. So you can even make your choice based on what the function looks like. So if I give you x equals some function of y, it's hard to solve for the y, then I'd have no choice. I'd have to keep it dy, in which case the line I'm rotating about will make the choice for me. Right? So there's that option. Well, which is hardly ever used. Usually you'll be able to solve for both of them. Because I want to sort of trick you into using the wrong one. So I'm going to make it look easy to do either way. You're like, oh, this is fine. Haha, got you. Should have been shell.
The whole thing wrong with it?
No, if you do it right, I'll give you the credit. But I mean, you do like twice the work by doing the more inefficient method. That's twice the amount of chances to make a mistake. And then I go 5 minutes left, and you start freaking out, and then you start making mistakes. So that's how it happens.
Solution, give us 10 minutes.
That's basically it. So homework for 7.3 due next time. Seven point four arc length. Basically just a formula. If f prime is continuous on the interval AB, then it's called arc length, but it's really just the length of the curve. The length of y equals f of x on AB is given by L equals the integral from a to b of the radical 1 plus f prime squared. Right, so that's like if you have a function, and boom, there's a curve doing something over here. That's A, that's B. Basically the idea is you cut this up into little points where you measure them with straight lines, and you're measuring the length of the straight lines. You end up finding the slope of the lines, which that's how the derivative is going to come into play. But the idea is if you want to find out the length of this, the distance between these 2 points, if you travel along the curve, it's given by this integral. Right? This is your function f of x. Again, we can switch to dy if it's appropriate. So similarly, if you're given x equals a function of y, and f prime is continuous on B, then the arc length of f of y on AB is given by so that's basically the formula. 1 plus the radical of 1 plus the derivative squared. Integrate that, it actually gives you the length of the curve between the endpoints A and B. Let's do an example. Now don't be surprised, sometimes these integrals are really horrible to work out. I'm just giving you a fair warning. So in your homework, you might not be able to work out all of them. but you should at least try.
Okay.
I'm gonna give you ones that can be worked out, so don't worry about that. As well as on the final, sometimes you see them say, set up the integral to find the length of the curve. You'll see that on final from time to time. It's because when they do this, the integral is like crazy. So they don't want you to waste time doing it. Let's say this, find the length of y equals x cubed over 6 plus 1 over 2x on the interval 1 comma 2. So the thing will look like that. What you're going to do is you're going to find the derivative, plug into the formula. Y prime would be?
X squared over.
What happened? Why was that so funny? What's going on?
He forgot to differentiate.
It's like, oh my god, really? I must need to go.
I forgot too. I'm not kidding.
It's been so long since we differentiated.
Power negative x, a negative 1, you know, so just add 1 more to it.
So it's
1 over negative 2x squared.
right. Wow. Okay, so if I do y prime squared, what is that? Don't tell me you forgot it.
You can't square each of them individually. You have to use the expanding thing again.
Yeah, that's giving Jhevon a big tip. Here's 100 points. Just take it. Just take it.
Just take it.
It ain't a thing. It ain't a thing. So how do you square this? What? Come again?
Factor out the 1 over 2, please.
You could do that. It won't really matter.
You have to use the expand the squares thing.
Yeah, so what is that?
Yeah.
X to the 4th over 4.
Minus 2.
No, 2 is get cancelled. Oh wait, still there's a half.
So I would get a half.
Half x. Wait,
Plus?
we get cancelled, yeah.
1 over 4.
1 over 4 x 4.
Okay, remember that.
Oh, like forever.
Remember.
Forever.
Forever. Yes. But in particular in the next 2 minutes. Okay, so now I'm going to plug that into my formula that I just erased.
Oh god.
So they gave me the interval. It's from 1 up to 2, so that's just my limits here. That's not going to be the big deal. I'm going to take the radical of 1 plus
You could just
all that, right?
just half instead of over.
How do you integrate that?
Easy. That's the power of squared. So we just expand the brackets and you know. So that's like x4 over 4.
What happens here?
X4 over 4 plus 1 over
X4 over 4 plus
1 over 4x4.
1 over 4.
plus a
Plus
half.
right, then plus
Plus
1 over x4. Same thing again. This is just,
Okay, and what's that? How do you integrate that?
that's part of the half, so wait, never mind, hold on.
1.
I'm just gonna
Can you
keep
combine
going.
it into one fraction and then try to make it so?
Oh. Well, maybe.
What would your substitution be?
The entire thing and then the yeah, no. Yeah, no.
1 over 2 times. square root of that. And you take the derivative.
That only works in polynomial, not the function.
Well, we can't just split up the radicals across this, right?
Yes. Why not?
Just take the point. Just take it.
Just take all of it.
Just take the 100. I don't care. I don't care anymore.
y squared.
Remember this.
Y squared.
Remember I said that.
I told you.
Oh.
I'm coming.
Oh, okay. Do we see it now? So what is it?
Y squared.
X squared over 2y.
It's just
Y
that.
squared plus
Yeah.
1 half.
What?
What?
What? What? Did he say y squared? Where did the y come from?
Right here. Right here.
What was this?
X squared.
This was actually what? Just x squared over 2 minus 1 over 2x squared, right? All squared.
But there's a plus half. Oh, plus half minus half. Oh. Or never mind. No.
What? What? Alright. Okay, so what does it look like?
S squared divided by 2 plus.
The half you can't see it because he's covering it, but it's up. Right.
That thing that I just factored looks an awfully lot like this thing, except the middle sign was changed.
Is it always?
So I pretty much went backwards and changed the middle sign.
Is it always the case? Or?
No, it's not always the case, of course not. This is just a really neat example that I skillfully picked. So now what? If my x is between 1 and 2, clearly these are all positive, so I cancel those. Technically it gets absolute value, but it's all positive, so it doesn't matter. It's just going to be the function. X squared over 2 plus 1 over 2x squared dx. Don't need a substitution. What's the integral?
Integral of that x.
U over 6 minus what?
1 over 2x is what he said.
Okay, so you plug the 2 in, you get 8 over 6 minus 1 over 4 minus, plug in 1, you get 1 over 6 minus a half. Here, that's 4 over 3. What is it? Well, I mean, 24 is going to be like the big thing, right?
Okay.
What? 12? Okay.
12 minus
So what goes here?
9 minus
3 to 12 goes 4 times. 4 times 4 is 16. 4 to 12 goes 3 times.
Minus
2 times
3.
1 is 3. 6 and 12 goes 2 times.
13.
2 into this goes 6 times. So what's that?
The 6 and 3 to get cancelled, so 16 over 12.
17. 17 over 12. 17 over 38.
Technically, that's all you need to know. I have a couple more examples. You can try the homework if you want. But
If you want. So it's not due.
It's not new.
It's not due.
fine, do the homework then. You have a whole weekend. Come on. Do the homework.
So wait, 7, 3, 7, 4.
7, 3, 7, 4.
Your class.
Why? Like why?
I did, but I